Okay, dear students, welcome to all fours e-learning classes. Students, I will repeat again yesterday concepts. First one, angle between the tangents. First, here two tangents. The two tangents drawn from an external point P to the circle S equal to 0. Here theta is the angle between the tangents. Then we have formula tan of theta by 2 equal to r by root s11. Tan theta by 2 equal to r by under root of s11. According to this formula, we have to find angle between the tangents. Okay, now next, also another formula for angle between the tangents, we have cos theta equal to modulus of s11 minus r square by s11 plus r square. S11 plus r square. Okay, next, if the tangents are perpendicular, then condition, if the tangents are perpendicular, then theta equal to 90 degrees. Therefore, we have condition r square equal to s11. The tangents are perpendicular. These two tangents are perpendicular, then condition r square equal to s11. Okay, next, contact. Chord of contact. Here, the line joining the points of contacts. The line joining the points of contact of the tangents to the circle S equal to 0 drawn from an external point P is called a chord of contact of P with respect to S equal to 0. In this diagram, here the chord AB, A comma B are the points of contact of the tangents. Here the chord AB is called a chord of contact of P. Chord of contact of P. Here the suppose circle equation is S equal to 0. The point P is x1 comma y1. Then the chord of contact of P, it means chord AB equation is S1 equal to 0. Here the chord AB equation is S1 equal to 0. The point P is given x1 comma y1. The circle equation is given. The equation of the chord AB. Here chord AB is nothing but AB is the chord of contact of P. Its equation is S1 equal to 0. Okay, next, here the point P lies outside the circle S equal to 0. And the chord of contact of P is a chord of the circle S equal to 0. If the point P lies on the circle, then the chord of contact of P is tangent at P of the circle S equal to 0. The point P lies inside the circle, then the chord of contact of P does not exist. Okay, next, polar and polar. Next, pole and polar. Here at S equal to 0 is a circle. S equal to 0 is a circle. P is any point in the plane. Here, any line passing through P meets the circle in 2 points. A comma B. Now, the point of intersection of the tangents. Drawn at A comma B. Lie in a line. That line is called polar of P. This line is called polar of P. Listen, here S equal to 0 is a circle. Here P is any point in the plane. Any line passing through P intersect the circle in 2 points A comma B. Now, the locus of the point of intersection of tangents the locus of the point of intersection of the tangents drawn at A comma B is called polar of P. In this diagram, here this line is called polar of P, and the point P is called pole of the polar line. The point P is called pole of the polar line. And next, also here circle equation is given S equal to 0. The point P is given x1 comma y1. In this case, equation of the polar is S1 equal to 0. Polar means line, pole means point. Here the point P is what? x1 comma y1. Circle is S equal to 0. Now the equation of the polar of P x1 comma y1 with respect to the circle S equal to 0 is S1 equal to 0. Here equation of this line is S1 equal to 0. Okay, some important points about pole and polar. Here students, here this is circle S equal to 0. P is any point in the plane. If the point P lies outside the circle S equal to 0, if the point P lies outside the circle S equal to 0, then the polar of P, this is the polar of P. The polar of P is a secant of the circle S equal to 0. And also the point P lies exterior of the circle, then the polar of P becomes a chord of contact of P. Here the polar of P and chord of contact of P equation is same, S1 equal to 0. Here the point P lies outside the circle S equal to 0, then the polar of P is a secant of the circle S equal to 0. It means polar of P meets the circle in 2 points. Here the point P lies outside of the circle S equal to 0, then the polar of P becomes a chord of contact of P. If the point P is given x1 comma y1, the circle equation is given S equal to 0, then the chord of contact of P and the polar of P equation same, S1 equal to 0. Okay, next. Second one. The point P lies on the circle S equal to 0. The point P lies on the circle S equal to 0, then the polar of P becomes a tangent at P. The polar of P becomes a tangent at P. And also the point P lies on the circle, then the chord of contact of P is a tangent at P of the circle S equal to 0. If the point P lies on the circle, then polar of P is a tangent of the circle S equal to 0 at the point P. Next. The point P lies inside the circle other than center. Here P is not center. The point P lies inside the circle S equal to 0 other than center. Then the polar of P does not meet the circle. Does not meet the circle here. This is the polar of P. The point P lies inside the circle S equal to 0. The polar of P does not meet the circle. Completely lies outside the circle. Actually, the point P lies inside the circle, chord of contact of P does not exist. But here polar of P exists and does not meet the circle S equal to 0. Okay, next. If P is center, if P is center, then the polar of P does not exist. Here, if the point P lies inside the circle other than center, polar of P exists and does not meet the circle. If P is center of the circle, then the polar of P does not exist. Okay, next. Here, polar of P does not exist, and also we can say pole of the diameter does not exist. Pole of the diameter does not exist. Okay, another point. The polar of P, this is the polar of P. The point P lies outside of the circle S equal to 0, then the polar of P meets the circle in 2 points. Here the polar of P is perpendicular to the line joining the center and the pole. Now these two are perpendicular. Always here the polar of P is perpendicular to the line joining the center and the pole. It is 1 point. Next, polars of the polars are concurrent. Here polars are concurrent, then the polar of the points are collinear. Polars of the points are collinear. Polars of the points means what? Poles. Polar of the point means what? Pole. If the polars are concurrent, then the polars of the points are collinear. Here these three are collinear. This means these three are poles. Here polars are concurrent, then the polars of the points are collinear. Okay, next students, pole of the line Lx plus My plus n equal 0 with respect to a circle x square plus y square equal to r square. This is x square plus y square equal to r square. This is the line. This is the line Lx plus My plus n equal to 0. This is the pole. In this diagram, this is circle equation. This is polar equation. Now it is pole. Pole is what? If the polar and circle equation is given, pole is what? Let suppose P x1 comma y1 is the pole of Lx plus My plus n equal to 0 with respect to the circle x square plus y square equal to r square. Here that P x1 comma y1 is the pole of Lx plus My plus n equal to 0 with respect to a circle x square plus y square equal to r square. Now that P x1 comma y1 polar of P x1 comma y1 with respect to s equal to 0 is s1 equal to 0. Implies here polar of P x1 comma y1 with respect to the circle s equal to 0 is what? S1 equal to 0. S1 for given circle x1 plus y1 minus r square equal to 0. Okay, here given line and this line. So this is equation number 1. Given line Lx plus My plus n equal to 0. Observe these two lines. This is what? Lx plus My plus n equal to 0. Actually this is what? Polar of P with respect to a circle x square plus y square equal to r square. This is also polar of P with respect to a circle s equal to 0. Therefore these two are represents same. 1 and 2 represents same line. Now coefficient of x here L, or coefficient of x here first x1 your coefficient of x L equal to your coefficient of y y1, your coefficient of y m equal to your coefficient of your constant n, sorry here, minus r square by n. Now x1 by L equal to minus r square by n, write as it is x1 equal to minus LR square by n, and y1 equal to minus m r square by n. Therefore the point P equal to minus LR square by n minus mr square by n. Here what is P? Pole of the line Lx plus My plus n equal to 0 with respect to a circle x square plus y square equal to r square. Here pole of Lx plus My plus n equal to 0 with respect to a circle x square plus y square equal to r square is minus LR square by n comma minus mr square by n. The question, the polar equation is given and the equation of circle is given, then the pole is what? Here according to this formula we can find pole of the polar line minus LR square by n comma minus mr square by n. Okay. The pole of Lx plus My plus n equal to 0 with respect to a circle x square plus y square plus 2gx plus 2fy plus c equal to 0 is minus g plus LR square by Lg plus mf minus n comma minus f plus mr square by Lg plus mf minus n. According to this formula, we can find the pole of the polar line Lx plus My plus n equal to 0 with respect to a circle x square plus y square plus 2gx plus 2fy plus c equal to 0. Okay, friends, here the chord of contact of 2, 1 with respect to the circle x square plus y square plus 4x plus 4y plus 1 equal to 0 is. The question, the chord of contact of 2, 1 with respect to a circle x square plus y square plus 4x plus 4y plus 1 equal to 0 is. You know, the point P is given and circle equation is given. The equation of the chord of contact of P is S1 equal to 0, but in the option here out of 4 option, one option is what? Not existing. First check the point P. The point P lies outside the circle, inside the circle, or on the circle. If the point P lies inside the circle, then this option is correct, not existing. Here the point P lies inside the circle, then the chord of contact of P does not exist. Here 2, 1, check S11 value. Here S11 2. Here for suppose 4 plus 1 5. So complete here plus terms. Therefore S11 value is positive. Here S11 positive. Therefore 2, 1 lies outside of this circle. If the chord of contact is exist. Therefore equation of the chord of contact of P. Here the point P lies outside of the circle. Reason S11 value is positive. Therefore chord of contact of P exists. This is the chord of contact of P. The point P lies outside of the circle S equal to 0. Then the chord of contact of P is a chord of the given circle. Its equation is what? S1 equal to 0. Equation of chord of contact of P with respect to S equal to 0 is S1 equal to 0. Now implies this is S equal to 0, this is x1 comma y1. S1 x x1 plus y y1 plus g of x plus x1 2 of x plus x1 2 of y plus y1 plus 1 equal to 0. Now implies the x1 2 2x plus y1 1 y plus 2 of x plus 2 plus 2 of y plus 1 plus 1 equal to 0. Directly here 2x plus 2x 4x y plus 2y 3y constant 2 into 2 4 plus 2 plus 1 7 equal to 0. 4x plus 3y plus 7 equal to 0. Second option. Here chord of contact of P exists and equation of the chord of contact of given point with respect to the given circle is 4x plus 3y plus 7 equal to 0. Okay, next problem. Pole of 3x plus 5y plus 17 equal to 0 with respect to a circle x square plus y square plus 4x plus 6y plus 9 equal to 0 is. Here comparing the given circle with x square plus y square plus 2gx plus 2fy plus c equal to 0. Here g equal to 2, f equal to 3, c equal to 9. Now radius under root of g square 4 plus f square 9, 4 plus 9 13 minus c minus 9 13 minus 9 4. Therefore r equal to 2 under root of g square plus f square minus c 4 plus 9 13 13 minus 9 4 under root of 4 is 2. Okay, next comparing given line with lx plus my plus n equal to 0. Here l equal to 3, m equal to 5 and n equal to 17. Lx plus my plus n equal to 0. Here pole we have formula pole equal to formula minus g plus lr square by lg plus mf minus n comma minus f plus m r square by lg plus mf minus n. Next minus g here minus 2 plus l 3 into r square 4 by lg 3 into 2 6 mf 15 minus n minus 17 comma minus f minus 3 plus m 5 r square 4 by same denominator 6 15 minus 17. Okay, next it is minus 2. Okay, minus 2 it is 12 by 21 minus 7 4. 21 minus 17 4. Next minus 3 plus 20 by 4. Next it is minus 2 plus 4 3 is minus 3 5 plus 5 here. Final answer 3 minus 2 1, 5 minus 3 2. Therefore 1 comma 2 is the pole of the line 3x plus 5y plus 17 equal to 0 with respect to a circle x square plus y square plus 4x plus 6y plus 9 equal to 0. Here it means This is polar. This is the circle. Polar and circle equation is given, and the pole equal to what? In this case, we have formula pole equal to minus g plus Lr square by Lg plus Mf minus n, comma minus f plus Mr square by Lg plus Mf minus n. Comparing circle equation with x square plus y square plus 2gx plus 2fy plus c equal to 0. Comparing given line with Lx plus My plus n equal to 0. After getting g, f, c or L, M, n, substitute in this formula, we get pole equal to 1, 2.